In this lesson, we're going to continue with more examples using dimensional analysis, specifically looking at the use of compound units. So again, we're focusing on converting values among units. A car is going 55 miles per hour. What is the speed in feet per minute? So having the miles per hour or the feet per minute is what I refer to as a compound unit because it includes two units within one value. So we're going to start with the value we're given, the 55 miles per hour. And we're not going to approach these problems really all that much differently than we did other conversions of units. The difference is that we have to deal with two different units, and we're going to deal with one and then the other. So first, we're going to look at miles, and we're just going to kind of ignore that the hours is there for right now. And we're going to convert from miles to feet because that's what we want to look at for our answer. We see that our starting value is units of a distance over time. We end with the units of distance over time. So we're going to first worry about getting from miles to feet. So I'm going to put miles on the bottom and feet on the top because what I want to happen is to cancel out miles. Now I have units of feet in the numerator and hours in the denominator. So if I stop the problem right here, I'd have feet per hour, but that's not what the problem is asking for, although we're closer than what we have. Now I'm going to focus on the time or the denominator, and I want to go from hour to minutes. So again, I set up my parentheses and my fraction, and in this case, because hour is in the denominator, when I do the conversion or the relationship, I want hour to be in the numerator. So I have 1 hour over 60 minutes, and then hour cancels with hour. At this point, the units that are left are feet in the numerator and minutes in the denominator, which is exactly what I want for my answer. So now I can do the calculation, and I get 4.8 times 10 to the third feet per minute. Let's look at another example that starts with 55 miles per hour again, but this time we're going to go to inches per second. We're still going to start the problem the same way, 55 miles an hour, and again I'm going to focus on one unit and then the other. It doesn't matter whether you focus on the units in the numerator first or the denominator first. You're still going to do the same setup and get to the same answer. I usually start with the units in the numerator, but there's nothing wrong with starting with the units in the denominator. So I'm going to start with miles. And I'm going to put miles in the denominator because I want those to cancel out, and put feet in the numerator. So at this point, if I stopped, I'd have feet per hour, which doesn't match with the units being asked for in the problem. Now I'm going to go from feet to inches, and feet cancel out. So now if I stopped, I'd have inches per hour. So the distance unit in the numerator is correct. The time unit in the denominator is incorrect. So now I have to focus on the time. And I want to get rid of hours, and so since it's in the denominator in my original value, it's going to go in the numerator in the next step, the next relationship. Hours cancel. I've got minutes in the denominator, but I want seconds. So now I can put minutes on the top and seconds on the bottom and cancel out minutes. Notice that as I went through this problem, all of my relationships are true, regardless of what value I started with. 5,280 feet is equal to 1 mile. 12 inches is equal to 1 foot. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. I solve the problem and I get 968 inches per second. When I round to the correct number of significant figures, I get 9.7 times 10 to the 2 inches per second.